Hey guys, and welcome back to another video on the channel. In this video we're going to be working out what 1 plus 2 plus 3 plus 4 and so on equals. Now you're probably thinking, we don't need to calculate that, it's just infinity. Well, you're wrong. Just kidding. Well, there's a couple of proofs that says that's not necessarily correct. There's a lot of problems with this stuff that I won't give my opinions on, but I'll show you the proof anyway for it. Okay. So to start off with, to work out, let's label this just S. Let's say we didn't know what this was. Let's say this wasn't infinity. Let's just call this S. This is our sum. This is our number we get when we add up infinity. Okay. So you can see this is all the countable numbers, all the integers. So 1, 2, 3, all the way up to infinity, pretty much. Okay. So let's consider this other sum. Let's call it let's say K, where this sum is 1 minus 1 plus 1 minus 1 plus and so on. So it alternates between 1 and negative 1. Now depending where you stop will give you a different number. So let's try and work out what this could be. So what we're going to do is we're going to consider 1 minus k. If we do that, all we're going to do is rewrite this whole thing in a bracket next to 1. So we'll write 1 minus and then we have k. So I'll put a bracket and then 1 minus 1 plus 1, so on and so forth. So if we distribute the negative here to all the values here, let's see what we get. We're going to get 1 minus k is equal to 1 minus 1 plus 1 minus 1 and so on and so forth. And what you can see is this is just k. So 1 minus k is k. So that means 1 is equal to 2k. So that means that k is a half, okay? Which is a bit weird, but let's take a look at it from another perspective. If we consider this infinite series here, let's say we stopped our series here. We get the value of 1. Let's say we stopped it here. We get the value of 0. Let's say we stop it here, we get 1. Stop it here, we get 0. So it alternates between 1 and 0. Now the average of 1 and 0 is a half, which is a bit weird as well. But anyway, let's move on. Let's take a look at another series that we're going to need for this as well. So let's consider the series, let's call this A. So A is equal to 1 minus 2 plus 3 minus 4 plus 5 minus 6, and then it goes on forever as well. So it's all the natural numbers except every even number is negative, okay? So what we're going to do to this is we're going to add it to itself. So we're going to go we're going to go A plus A, but we're going to do it in a particular way. We're going to add it to every we're going to add it to every second term. So we'll start our sum here. All we're going to do is move it down. So this is going to be minus 2 plus 3 minus 4 plus 5, so on and so forth. So if we add this, we have 1. So 2A is 1. Negative 1 plus 1 is going to be negative 1. 3 plus minus 2 is 1. Negative 4 plus 3 is minus 1. And if you do this for every single number, you're going to get the series K, if you check it out. So we can see this here is just this sum up here that we just looked at before. Okay? So what we have is 2A is equal to K, and now we worked out what K was. K is a half. So we go 2A is equal to a half, therefore A is equal to 1/4. Okay. Now that we have this here, what we're going to do is we're going to look at another series. Okay. So let's consider the sum of positive numbers again, so S, so 1 plus 2 plus 3 plus 4 plus 5, yada yada yada. Okay? And let's consider our series A. So A we said was, what was it? 1 minus 2 plus 3 minus 4 plus 5. Okay? What we're going to do is we're going to take our sum S and minus A. Okay? So minus all these from this. So what we're going to get here is 0. What we're going to get here is well, negative times negative 2 will be 4. Not 4, 2. 2 plus 2 will be 4. So distribute this to every single term, and there's an infinite amount there. Ooh. Plus dot 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 dot. So distribute this to every single term and add it to this series here. Okay? So that's going to be 0. This is going to be 4. This is going to be 0. This, plus. This is going to be plus 8. 0. Plus 10. And we're going to start to see a pattern starting to emerge. Oh, not plus, that's 0. That's not 10. That'd be 12. Right. So if you do this for a while, this is what you're going to get. 4 plus 8 plus 12 plus 16 plus dot dot dot. What we get is series S times by 4. So you can see if you took out a factor of 4 out of all these, you get 1 plus 2 plus 3 plus 4 dot 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 forever. Okay? And this is S minus A. Now this here is clearly 4 of our sum. So we can replace that now with that. So S minus A is equal to 4S. Now we know what A is. A is a fourth. So what we have here is S minus a fourth is equal to 4S. So what we effectively have is minus 1/4, and then we have 4S minus S. So since we get negative a fourth is 3S, and therefore S is equal to negative 1/12. So 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc., etc. Do that for a while and you should get negative 1/12. Now, I'm not going to give my opinion on this proof because Ramanujan also proved this and he's a brilliant mathematician, but I'll leave this up to you guys for interpretations, whether this proof is valid or not. Anyway, I hope you enjoyed the video. Like and subscribe.